Hey there, ladies and gentlemen. Today we are going to do our last section um, in this first part of the geometry unit in Math 4. And so today we're going to talk about section 2.6. It's on special angles on parallel lines. So first thing we need to talk about is a little vocab. That line T is called a transversal. Transversal is a line that cuts two or more lines. It creates many types of angle relationships. So T is the transversal cutting through A and M. We see all these different angles formed, 1 through 8. And we're going to talk about the angles and their relationships. First thing we're going to talk about is corresponding angles. Those are angles that occupy the same relative position. So for example, angle 1 here, if I was to pick line A up and lay it on top of line M, 1 and 5 are going to find the same spot. Okay, then 2 and 6 are also going to. 4 and 8 will be in the same spot, and then 3 and 7. Those are corresponding. So their angles are in the same spot if I was to pick line A up and place it on top of line M. We have alternate interior angles. They're angles that are on opposite sides of the transversal. They're both inside lines A and M. So for example, we have 3 and 6. See, they're on their opposite sides of the transversal, but they're both inside my lines. Then we have 4 and 5 are also alternate interior lines. They are inside, but on opposite sides of my transversal. Then we have alternate exterior angles. These are angles that are on the opposite sides of the transversal again, but they are outside of the lines. So those would be like 1 and 8 and 2 and 7. They are on opposite sides of my transversal and they are outside of my lines A and M. So those are the three types of angle relationships we see. But we can talk about their measures specifically if the lines cut by the transversal are parallel. So now I've made A and M parallel by those little arrows. Remember, those indicate that they're parallel. Now, now we can talk about their angle measures for the angle relationships. So we can make these conjectures because of vertical angles and supplementary angles. So vertical angles we would know would be like 1 and 4. Well, vertical angles are going to be congruent. Okay, so let's just make some angle measures up here. If I said angle 1 is 135 degrees, I'd say that angle 4 was also 135 degrees. Then I can use the idea of supplementary angles to find measures for angle 3 and angle 2. Supplementary angles are two angles that form 180 degrees. So in this case, if I have 135 for angle 1, angle 2 needs to measure, well, take 180 minus 135, and we are going to end up with 45 then. Again, using that notion of vertical angles, I know that angle 3 is also 45 degrees. Now, if I take angle or line A and I lay it on top of line M, those angle measures are all going to carry over. And so we're going to see that this is 135, 45, 45, and 135. So let's do some conversing about these angles and their relationships we just finished talking about. So we said, let's talk about corresponding angles. So corresponding angles we talked about are angles that are in the same spot. So if we look, my corresponding angles for 1 and 5 are both 135. Let's see if I look at corresponding angles for 2 and 6, they both end up being 45. So what we can conject is that corresponding angles are going to be congruent. All right, let me get rid of those. Now let's talk about the alternate interior angles that we talked about. So those would be like 130, angle 4 and angle 5. Those are our alternate interior angles. We could also look at angle 3 and angle 6. Those are alternate interior angles. Well, what can we say about alternate interior angles? they're also congruent because of our vertical angles and our supplementary angles. Okay, so now let's take a look at the last angle relationship we talked about, which was alternate exterior. So 1 and 8 and 2 and 7. These are alternate exterior angles. We notice that the two blue circles or the two yellow circles are congruent again. So we can make the statement, if two parallel lines are cut by a transversal, then corresponding angles are congruent. Alternate interior angles are congruent. And alternate exterior angles are congruent. So, is the converse true? Could we say that angles that are congruent are alternate exterior or alternate interior are corresponding? Well, no. We have lots of angles that are congruent, but that does not necessarily mean that they are corresponding alternate interior, alternate exterior. They can't be all of them at once. All right. So, here's your assignment for your 2/6, and we will see you guys later.